Good morning. I am Vanda Ho. I am a consultant geriatrician at the National University Hospital and a PhD candidate in immunology at the National University of Singapore. I am sorry I cannot be with you in person for this conference, but I am grateful for the opportunity to share my work and to connect with you virtually. This is part of my PhD work, COVID-19 responses in older adults. From the COVID-19 pandemic, it is clear that older adults are intrinsically more vulnerable to infections, with a disproportionate morbidity and mortality worldwide. Vaccines were rapidly rolled out to mitigate these effects, but data emerged showing older adults experienced a weaker immune protection from these vaccines. This is also basis for our Health Ministry's guidelines for adults 60 years and above to be continually vaccinated to ensure they maintain their immune protection. These guidelines are similar across other nations as well. We might think COVID is a thing of the past, but is it really? Since the turn of 2025, COVID cases have again been rising globally, and the risks to older adults remain. My question therefore is, why are older adults persistently vulnerable, and what exactly about immunosenescence attenuates their vaccine response? So I'll leap into my first story. So I'll start with my first story, COVID-19 vaccination. I established the Voyage study, vaccination in older and younger ages. I leveraged on Singapore's national rollout of COVID-19 mRNA vaccination to study the older adults' immune response to a common novel stressor. We aim to assess the impact of age on immune responses after 2 doses of the Pfizer vaccination, focusing on antigen-specific T cells. The data I will be showing is from the first 3 time points: baseline before the first vaccination dose, at 1 month before second, and at 3 months before the post first dose vaccination. Importantly, none of our cohort up to this point had COVID-19 infection. Below in grey puts into context what was happening in Singapore during this time point. From June to September 2021, the country still had social distancing measures and restrictions imposed on work and dining. This was largely to stem the Delta wave. There was also a national push for vaccination, which reached our shores in December 2020. From September to December 2021, the dominant strain was Omicron. As majority, 87% of Singaporeans were already vaccinated at that point, vaccine differentiated measures were introduced as the society gradually opened up. This is our study workflow. At every study visit, blood work was done for neutralizing antibody responses against SARS-CoV-2 variants, as well as changes in B and T cell subsets by high-dimensional flow cytometry. Antigen-specific T cell responses were also quantified by intracellular cytokine staining and flow cytometry. What did our cohort look like? Altogether, we recruited 15 younger and 7 older adults. There was good age separation, with the median age of our young adults at 31 and the median age of our older adults at 72 years old. Our younger adults were physically more robust compared to our older adults, as measured by our short physical performance battery, which is a series of 3 tests where the adult would have to do balance, gait speed, as well as chair stand. We dive straight into the immunological responses. To orientate, the young are in blue, the old are in red, and the x-axis are the time points. Day 0, when there's no exposure to SARS-CoV-2 at all, day 28, after the first vaccination, and day 100, which is 2 months after 2 doses of the vaccine. The y-axis here is global IgG, which means that it is not specific to the SARS-CoV-2 antigen. So we can see that global IgG secreting memory B cells did not significantly rise in older adults in response to 2 doses of vaccination. However, if we look at the wild-type specific IgG response, both younger and older adults had significant increases, though younger adults had a brisker response after just 1 dose of vaccination. We then looked at the neutralization responses to wild type and Omicron. Despite the smaller B cell responses in older adults, neutralization responses at day 100 was equivalent across the ages. Again, young is in blue, old is in red, x-axis is the time point, and y is virus neutralization by ACE2 inhibition. In our young, there was significant rise in neutralization after just the first dose, but the older adults needed 2 doses of vaccination for a significant rise. This trend was also seen with alpha, beta, delta, and gamma strains, which are not shown here. It's unsurprising that there was insignificant viral neutralization activity to Omicron strains, which was the dominant strain at this point, as the vaccine that all our participants received were designed to the wild type strain only. Moving on to our T cell responses, older adults did not experience an increase in TFH cells with vaccination. Again, young in blue, old in red, x-axis is time points. So we define T follicular helper cells as ICOS positive, PD-1 positive CD4 T cells, and this is on the y-axis. This makes sense with our story so far, that our older adults had attenuated T helper response to vaccination, and with less T cell help, there is then less B cell response. So far, we have looked at the global immune response. We also examined SARS-CoV-2 specific response, and how we did that was by incubating blood samples with the wild type spike, Omicron spike, and nucleocapsid proteins. After overnight incubation, we then measured the T cell cytokine response using flow cytometry. So this looks at the polyfunctionality of the CD4 T cells of our young and older adults. The first row are our young adults, and the second row is our older adults. Across different time points from day 0 to day 100 from the left to the right of the screen. The number of cytokines produced is represented by the colors on the pie charts, and the ones we are looking at specifically would be the red for 3 cytokines and yellow for 4 cytokines respectively. If we look at the wild type on the left-hand side of the screen, young adults had significant increase in the red and yellow areas with 2 doses of vaccination. However, in the row below, our older adults had these areas contracted over time instead. At day 100, there were significant differences in the young versus older adults. A similar picture is seen in Omicron as well, suggesting that there are shared components in the peptide pool, which was then presented to these CD4 cells. Aside from looking at global cytokine production, we also wanted to look specifically at which cytokines were implicated. Again, young are in blue, old are in red, and the x-axis are the time points. The y-axis here are the SARS-CoV-2 wild type, Omicron, and nucleocapsid specific CD4 T cells, which are only secreting interferon gamma. Our younger adults had a significant increase in interferon gamma secreting CD4 T cells to wild type and Omicron, but this was not seen in our older adults. Unsurprisingly, we don't see any signal changes with our nucleocapsid as no one had infection at this point. We then correlated this interferon gamma response with neutralization activity. The blue line here is the young, the red line is old. Our x-axis is virus neutralization, and our y-axis was the interferon gamma only secreting CD4 T cells, which we saw in the previous slide. So not only did our young adults exhibit a significant increase in their interferon activity in CD4 cells, this interferon gamma response was also strongly positively correlated with the functionality of SARS-CoV-2 neutralizing antibodies. So it was a strong positive relationship with a Pearson correlation coefficient of 0.74. Conversely, this relationship is negative in older adults. So in summary, we found that community-dwelling older adults have an attenuated antigen-specific T helper cell response to COVID-19 mRNA vaccination. and this was correlated with an impairment in their serological immune correlates for SARS-CoV-2. This relative interferon gamma secreting CD4 T cell deficiency in older adults might provide a mechanistic explanation for their poorer COVID-19 vaccination responses, and we have successfully published this in Aging Cell. So a little bit about interferon gamma. What about it makes it crucial in immunosenescence in our context of COVID-19, of course? So interferon gamma is key in antiviral responses and also for other intracellular infections such as tuberculosis, TB. And this might account for the higher morbidity and mortality that older adults get from such infections. The second is that it does fit with the immunosenescence changes that we see with a shift from Th1 to a Th2 response. After all, interferon gamma is the pivotal cytokine in inducing Th1 responses, and a relative deficiency would then lead to a skewing of the response towards Th2. Our next steps are to analyze if similar interferon gamma deficiency is also seen in COVID-19 hybrid infection, which is infection after vaccination, and if it is generalizable to other intracellular infections such as TB, which I have mentioned. So we'll move swiftly on to our second story, which is on COVID-19 hybrid immunity, and I'll be showing unpublished data. So we'll go back to our timeline again. We have talked about the first 3 time points at day 0 to 3 months, and now we want to focus on the later 3 time points, which is 6 months to 2 years. At this point, most of our cohort have already experienced infection, and we want to see if there's things that has happened at baseline at day 0 that we can observe at 2 years. So importantly, what we wanted to see in the context of a novel antigen is whether there's a relationship between baseline inflammation, which we measured using the O-link inflammation target 96, and future immunosenescence, which we defined by KRRG1 and CD57. Why is this important? This has implications of prognosticating those who might not do well with infections, particularly novel ones, as well as provide potential therapeutic avenues to mitigate infection-related sequelae in older adults. Aside from immunosenescence, we also wanted to see if there was any relationship with immune exhaustion, which we defined as an elevated expression of PD-1, which is an inhibitory receptor. So exhaustion is different from senescence. Exhaustion is a state of cellular dysfunction due to prolonged or repeated antigen stimulation, versus immune senescence, which is a state of irreversible cell cycle arrest, usually in T cells, where they are unable to proliferate effectively. What we found is that baseline inflammation was linked to senescence, but not to exhaustion in COVID-19 hybrid immunity. So with our x-axis being our inflammatory score, and our y-axis being the frequency of KRRG1 CD57 dually positive T cells, we can see that there is a significant positive relationship with our inflammatory score. However, with the graph on the right, our y-axis is exhausted cells, so PD-1 positive T cells, and there was no significant relationship seen. So in summary, our first story with COVID-19 vaccination showed that older adults had a relative interferon gamma CD4 T cell deficiency, which might explain their poorer neutralization responses to vaccination. For future work, we will be investigating if the same phenomenon is seen in COVID-19 infections as well as latent TB infections. And really what we are looking at is whether there is a common signature in immunosenescence across infections which disproportionately affect older adults. Our second story looked at COVID-19 hybrid immunity, and what we found was that baseline inflammation at day 0 was positively correlated with future immune senescence but not exhaustion at 1 year and 2 years in the context of a novel antigen exposure. So in terms of future work, we do want to correlate with COVID-19 infection outcomes to see whether there would be any clinical value in this baseline inflammation score in terms of prognostication or perhaps with therapies. Before I end, I want to take a moment to acknowledge my PhD supervisors, Paul and Catherine, as well as all of PAMLab who are ever so supportive in my PhD journey. Thank you very much for your time. I'm always happy to connect and collaborate, and I will leave my email here.